Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here and this is our second video on collecting like terms. So, what have we already done? Previously on Hegarty Maths, I asked you to collect like terms for an expression like this or simplify an expression like this. It meant the same thing. Pause the video and double check you actually know how to do that. Well, I would expect you to see you getting your highlighters out and say, well, I've got 2x and I'm going to add a 7x, and then say you've got a positive 5y and you're going to add a positive 1y, which you might write a 1 there, and you might even say then that you've got a positive 1z and you're going to add a 3z. And collecting like terms, I would expect you to say this was 9x, add 6y, add 4z. And I would expect you to use the identical sign there. So you know how to do that, and I hope that makes perfect sense to you. Now this is the type of thing we're going to do in this video. More of the same, but just a tiny bit different, and see if you can tell what's going on here. What are my like and unlike terms here to each other? Well, here I've actually got something else going on. I've got x squareds. And although you might think they might be like something with x in it, they're not. X squared is a different entity to just an x. Okay, just like 5x is different to 5. X squared is different to x. So when we're collecting like terms, we think about all the things with x squared, let's say. We have an x squared there, we add 2x squared, then we're going to go for our x's. We've got a positive 5x and a positive 1x. We might even write the 1 in there. And lastly, numbers are their own entity as well. They are like. You can collect numbers together. You've got a positive 2 and a positive 9. So in the same way as we collected above, we've got an x squared and we add 2x squared, so we've got 3x squareds. We've got a positive 5x and we add a single x, so we're going to have add 6x. And we've got a positive 2 and we're adding 9 to that, so we've got positive 11. And that's what we're doing in this video, examples like this, just where it's not maybe x and y's, where it's maybe x squareds, where it's x's, and where it's numbers. So just to show you it's more of the same, but just slightly maybe harder. Right, let's do some examples. For each one, please pause the video and try before you see my answer. Okay, what would you do for this one? Well, we've got an a squared, and we're going to add an a squared, and we're going to add another a squared. And so we're going to have, this is identical to 3a squareds. Simple. What about the next one? Let's highlight our like terms. We've got an a cubed, so we're going to add a 3a cubed to that. They're like. We've got 2a squareds, right? And we're going to add 4a squareds to that, so they're like. And we've got a positive 1a, and we're going to add positive 9a to that. I might even write the 1 in there so I don't make any mistakes. Right, so let's collect like terms here. We had a cubed and we added 3 lots of a cubed, so we have 4a cubed. Remember that just means 1a cubed, doesn't it? Then we've got 2a squared and we add 4a squared, so we're going to have ourselves add 6a squared. And we've got 1a and we're going to add 9a, so we're going to have ourselves 10a. And just a little note here, when I write these, do you remember when I had x's, y's and z's, I wrote them out in alphabetical order? With these, I write the biggest power first, and this has a power of 3, this is a power of 2, this is a power really of a 1. I write them from biggest to lowest power. That's just mathematical convention. Alright, let's have a go at another one. Pause the video, have a go. Right, I'm going to highlight my like terms. I've got p squared there, which is really 1p squared. That's the only p squareds I've got, so I'm going to move on to q squareds. I've got positive q squared there, which is really a positive 1q squared. Oh, and look, I've also got a positive 3q squared there. Alright, then what have I got? Well, I've got positive 5pq, and I've got a subtract pq, which is really subtract 1pq. And I've even got another one here on the go. I've got a positive 5 and I've got subtract 7. So I've actually got how many like terms here? I've got 1 type of term, 2 types of term, 3 types of term, 4 types of term. So let's collect this up and see what we get. Write our identicals to sign, And let's go for highest power first and in alphabetical order. So 1p squared with nothing else is just a p squared. Let's go for other higher powers, which are q squareds. I've got 1q squared, add 3q squared, which is 4q squared. Let's maybe go for the pq's next. And we've got 5pq, take away 1pq, which is positive 4pq, so we write plus 4pq. And we've got 5 take away 7 by the symmetry of subtraction, that's negative 2. So we just write negative 2 there. And we're done. That's it for that one. Right, let's try another question. Pause the video and see if you can have a go. Now, this question asks us to write an expression for the perimeter. Now, the perimeter is the length around the outside of this rectangle, so it's this side. We're going to add that side, and we're going to add that length there, and we're going to add that length there. So let's write an expression down. We're going to have 4x, and we're going to add another 4x, and then we're going to add 5 subtract 2x, and another 5 subtract 2x. And this is just about collecting like terms, isn't it? We've got 4x's, add another 4x's, take away a 2x, take away a 2x, and we've got ourselves positive 5, add another 5. So collecting like terms for that is going to be nice and easy. 4x add 4x is 8x, take away 2x is 6x, take away another 2x is 4x, and positive 5 add another 5 is positive 10. There you go, that's our expression for the perimeter. We weren't given units, centimetres or whatever, so we can just leave it like that. Last question. Pause the video, have a go. Which of any of these is equivalent to x subtract 2? So what we've got to do is look at these three things, collect like terms or simplify them and see if any of them match up to x subtract 2. Let's do the first one. Got an x squared and we're taking away an x squared. There's going to be no x squareds there. Then we've got a negative 6x and we're going to add 7x. So we're going to get a positive 1x there. And lastly, we're going to have a negative 1 add 3, which is going to be positive 2. Now, because we've got x subtract 2 here, we don't have a negative 2. This one's going to be close. It actually simplifies, quite close, but it simplifies to x plus 2. So that isn't one of them. Let's do the same with the below. Got x squared, take away an x squared. That gets rid of the x squared, which is great. We've got a 5x, take away a 7x, which is negative 2x's, and then we're going to add 3x, which is going to be positive x, and we've got to take away 2. So this one is x subtract 2, which is great because that one is one of the answers. And the last one, we've got 5x and we're going to add 3x, which is going to be 8x, and we're going to take away 7x, which is going to be a single 1x. And here we've got negative 3 plus 3, which is just going to be 0. So this one actually just in fact simplifies to just a single x, which doesn't match x subtract 2. So that again is not 1. So which of the following is equivalent to that? The second one, B. And that's it for this video. Thanks for watching.